The ages of the 4 U.S. presidents when they were assassinated in office are 56, 49, 58, and 46. Assuming that 2 of the ages are randomly selected with replacement, list the 16 different possible combinations. Then find the mean of the 16 samples and summarize them in a table representing a probability distribution. Compare the sample mean that we get from that probability distribution with the population mean. So first of all, let's actually calculate the population mean. So to do that, this is the mean, like just how you would calculate any mean of 4 numbers. So that is, add them all up and divide by the total number of numbers. So in this case, we'll get 56 plus 49 plus 58 plus 46. And divide that all by 4, gives us 52.25. 52.25. Now, what we'll do is we'll assume that these are just 4 numbers in a box, so to speak, and we're going to pick one out and then put it back and pick another one out and see what we get. Then, so that'll be our sample of 2, and then we'll calculate the mean for each of those samples. So let's start there. So I'm going to come over to a blank page and start listing out the possible combinations of sample size 2. So that is, I could get 56 and then pull out a 56 again, or I could pull out a 56 first, put it back, and pull out a 49 next, or maybe a 56 first and then a 58. Now there should be 16 of these. This is going to be a lot of writing, so I actually prefer to do this in Excel. You're more than welcome to do it by hand, but if you're comfortable using Excel at this point in the semester, go ahead and use it. So if I switch over to an Excel spreadsheet, my spreadsheet will look like the following. So here I've started entering things in a spreadsheet. If I finish out the list here, these are all 16 possible combinations of pulling 2 of those numbers out of a box, essentially. The next thing I want to do is calculate the mean of each of those samples. So I should be more careful. I couldn't figure out how to put a bar over x in Excel, but this should be x bar to represent my sample mean. So the sample mean between 56 and 56, if I add them together and divide by 2, I'll get 56. So again, I want to do this. I want to find the sample mean for each of these samples. I'm going to throw those into Excel and get the following. So now I've got all my sample means listed out. The next thing I want to think about is, what is the probability of me getting, for instance, this first sample? What's the probability of me picking a 56 and then a 56 out? Well, since there's 16 different possibilities here, the probability that I would come up with this first one is just 1 out of 16. So that's going to be the same for each of these samples. There's a 1/16th probability that that's the sample that I'd get. So now I've got 1/16th listed for each of the probabilities for each sample. The next thing I want to do, in order to calculate the sample mean, or the mean of this probability distribution, is I need to calculate x times px, and then finally add all those together. Because if you remember, to find the mean, that was the sum of x times px. More specifically, in this case, I really should be talking about the mean of sample means is the sum of my means times the probability of my sample mean. So give myself one more column to multiply x times px columns. So I do that for each of my samples, and if I add up this entire column, I will get a sample mean of 52.25. So what we just showed was that the mean of sample means is the same thing as the population mean. In other words, the mean of my sample means equals the population mean.